Hello everyone, my name is Mohit Raj and you are watching Python parallel programming series. In the previous video we have seen the multiprocessing, means process class. So in this video we will see the communication between the processes. Python process do not share usual list and dictionary. However, the list and dictionary created by the process manager is shared by the process. So they can share the data via three options, which are file, shared memory, and communication channel. So before jumping to these file, shared memory, and communication channel, let's see the usual behavior of process with list and dictionary. So let's create a program from multiprocessing processing import process manager. No need to use manager, just current process. So here I am creating a normal list, built-in list, and defining a function worker which can take this list and a number, list one and number, num. So in this list, I am going to append that number. So print list one by the current process name and list one. What is the status of this list one right now? P1 create the process. So this should be capital. That's why I'm not getting, yes, now I'm getting the process. I'm defining the name. So I'm setting a name worker1 and target equal to target to worker function, worker. And what are the arguments? Args equal to a list which contain this global list. Okay, list one. And a number I'm using 10. Okay, then P1, P2. So simply start this. I'm copying and pasting here for P2 process. Worker is worker 2 and number should be 20. Everything's fine and let's start this process. P1 dot start and P2 dot start. Now I'm running these processes. Python processes 2. No more dual name. Okay, let's check the spelling. Okay, yes, it's some spelling mistake. Yes, so this is an error. Sometime Windows gives the error, this kind of error, not spot, not spot. So in that situation, we have to use the Linux. So let's switch to the Linux. Now you can see this program here, and this is I have copied this program in my Ubuntu machine terminal. So here this is my program process one. So I am just running this one Python 3.8 version and process. Okay, yes, I'm getting list by worker one, this one, list by worker two, this one. So each process, as you can see, every list is different. The list used by worker one and worker two are separate. That's why each list contains different values. Each process has its own address space. Thus, the process do not share the variable. So the inter-process communication IPC will be used to share the data among the processes. I think you got this sense. So usual list and dictionary cannot be used for the processes in order to share the data. So that's why we use file, shared memory, and communication channel. So file, file means file writing the data in the file, and other file can read the data from that file. That involves the hard disk operation. So this is not a good option to share the data. Okay. So I am using the shared memory and communication channel. You can see this one, process 1 and process 2, shared memory and communication channel are the two ways to share the data. Let's see the first, shared memory. In the multiprocessing communication, not values, it's a value, array, and manager are used to share the state. So for the shared memory, we have three ways to share the data. So let's explore the value. So what is value? We use value to store single number by using the following syntax: value type code, args loc. The value returns a shared memory object. By default, it returns a synchronized wrapper for the object, and the object itself can be obtained using the value attribute of value. So in the value, there is attribute value. So we can call it like a value.value. The type code or type, this one defines the return type of the object. So this time we have to define the return type of object. It may be integer, double. Okay, if we are expecting an integer, then use I. D for double. This is like a C language we have seen in the C. If you have ever learned the C language, in the C language, like D for double, D for integer. But here we need to use I for integer, D for double, and F for float. So see this table. B for signed integer. If we are expecting, we are going to get B, then use signed integer. We use small b, lowercase b. Unsigned integer, use capital B. Okay, so I have listed the table here. What we are expecting, use the type code. ARGS star argument specifies the size or initial value. If the loc is true, the default and new recursive loc object will be generated to synchronize the value. The purpose of loc, rloc or loc whatever, is to synchronize the access of the object. If loc is false, then access to the returned object will not be automatically defended by a loc. So let's see one example. Now let's see the example. So I'm using in the Ubuntu environment again. Import. First of all, save this one, process2.py. Import multiprocessing. Import time. Def shared. Any name, I'm using shared, and v is a variable here, argument v dot value equal to v dot value plus 1. Print sum of square v dot value. So now I'm printing a statement. Current value is v dot value. Now I'm creating the processes. So here, now I'm going to define the value. What is this v? Now let's define this v because I'm sending as an argument. We need to define here. So val equal to multiprocessing processing dot value. Now here's the syntax. So I'm expecting a integer, so I'm using I, and nothing as an argument, so I'm using 0. For let's create two processes, multiprocessing dot process target. I can use five loop, miss five, sorry, I can use five processes. Instead of creating just process, I can use a for loop to create the five processes. But I am creating only three processes without using for loop. So target is what our shared function, and args argument is our val. This val as an argument. This is special variable type of multiprocessing value. I is an integer and comma. Similarly, I can create multiple times, and here P1, P2 and P3. After that, join P1 dot join, P2 dot join, P3 dot join, and in the end, print the value outside main process val dot value. Okay, so this val dot value inside, because I'm sending this val here, and v is a parameter which can take this val as an argument, and we here I'm incrementing the value one by one, means I'm using three processes to execute this shared function. Each process add the value. Now if the multiprocess shared the this v dot value, it means that every process should increment the value. Okay, one thing, p1 dot start. Main thing we have forget that to start, p2 dot start, p3 dot start and join. Okay, now you can see current value is 1, current value 2, 3, and main process got the 3. So means now you can see this one, this value dot value is shared by the all processes. That's why every process incrementing it by 1. So in the next chapter, in the next video, in the next video, we will see the array. So stay with us, stay tuned for the next video. Bye bye, and thank you for watching this video.